Okay, so in these sessions, we will study about the control flow of the program. So most of the control flow still applies to C++. Such control flow includes if-else, for, while, do-while loop, switch, and ternary operators. So this branching and loop statement decides the control flow of the programs. Since such loops and branch statements are basic stuffs, I'm sure most of you have already learned them in C programming class. So since this class focuses on the differences and extended features of C++, so I will skip them here. If you have not learned these loop and branching statements before, please read the books. Any C++ book will explain these branching and loop statements. Or if you Google them, you can find a lot of information from there. So please study them in your own time and let me know if you have any questions. So for today, I will introduce you the range-based for loop and some of the pitfalls when we are using loop and condition statements. So let's talk about the range-based for loop first. This is a new stuff in C++. C does not have this range-based for loop. So C++ 11 includes a new types of for loop, which we call the range-based for loop. So this is the syntax of the range-based for loop here. We put the array to iterate here and declare the variable here with the data type of the elements in the array. So var name here is set to its successive elements in the array. So by referencing var name, you can access each element in the array. So this is very useful features. It makes us to easily iterate over elements in the array. Let's see the example code for range-based for loop. Okay, so this is the first example code of the range-based for loop. Let's first compile this code and execute. So when we compile this program and run it, this program produces these outputs. So there is a int types of array. It has 4 elements, 20, 30, 40, 50. And here we are using a range-based for loops. We put the array here, the array that we need to iterate, and put the variable here, and we need to specify data types of each elements of this array. But since we are using an auto keyword here, this will automatically infer the data type of arrays elements. So we don't need to worry about data type here. And we are referencing this x variable name to access the array element, the value of array elements. So here, the first element of this array is 20. So it prints 20 here. And it iterates again, and the second one is 30. So by referencing this variable x, by printing this x, we can print 30 and 40 and 50. So this is how we use our range-based for loop. The range-based for loop allows us to iterate array easily and makes your code simple. So if you do not use a range-based for loop, we have to iterate array like this way. So since you learn C programming language, in C you iterate array like this way. So in this case, you have to calculate the last elements, the size of the array by using size of operator like this way. And you have to also worry about the increment statements. So if we compile this program and run it, so this for loop and this for loop produce same output. But as you can see here, this for loop looks more messy and this looks more simple and beautiful. So this is the reason why you need to use a range-based for loop. Now let's look at the example 2 code for range-based for loop. So now we are iterating the character point array A, B, C, D like this using a range-based for loop. Let's compile this program and see how it goes. Okay, so if we compile this program, compiler error occurs here. It says that invalid range expressions of type character, no variable begins function available. So compiler does not know the begins and end, the range of the character point array. So you cannot use the range-based for loop for the pointer array pointers like this way. So so keep that in mind when you are using a range-based for loops. You cannot use a pointer. Okay, so let's go back to the slide. The range-based for loop can be divided into pass by value and pass by reference. The example of range-based for loop we studied in previous slide is based on the pass by value. In this case, we cannot change the value of each element in array. So if you want to update the elements of array using a range-based for loop, you have to use a pass by reference by adding this ampersand symbol. So let's see the example code for this one as well. Okay, so first compile this code and execute it. So if we execute this program, it produces this output, but this is not expected because we are using range-based for loop here and here. In the first range-based for loop, our intention was to increase the value of each element of array by 1. So here we iterate array using this range-based for loop, and we increment the value by 1 using this operator. So our expectation was to print 21, 31, 41, and 51. But when we actually print this array, the value did not increase. This is because this is based on the pass by value. If we want to update the value of array elements, we have to use the pass by reference. So if you put ampersand symbol here, now this range-based for loop is based on the pass by reference. If we compile this program and run it, now the program's output is 21, 31, 41, 51 as we expected. So this is the difference between pass-by value and pass-by reference. So don't forget that if you want to update the array elements, you have to use a ampersand symbol here to make the range-based for loop as a pass-by reference. So what is the difference between pass-by value and pass-by reference? Let's explore that with example code. So let's compile this code and see the output first. Okay, so here I print the address of each element in the array. So element 1 consists of 20 value, and its address, memory address, is this one, F0. And the second element consists of 30 value, and its memory location is this one, F4, and third one is F8, and fourth one is FC. So this is the address of the elements in array. And if we print this X address, so as you can see here, we use the ampersand symbol here. So we are using range-based for loop based on the pass-by reference. So if we are using a pass-by reference, and if we print this variable's address, as you can see here, the address, this X value pointing to is exactly same as the address the array, each element's arrays are pointing to. So F0, F4, F8, F7 is same as this address. So because this X is pointing to the same memory address as the array elements pointing to, so if we change this X value, it can also affect to the actual value in array elements. But on the other hand, this range-based for loop, you're not using an ampersand symbol here, so it is based on the pass-by value. If we print this X variable's address, as you can see here, this address is different to the above address. So it's F1, 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 which is different ones. So since this variable pointing to different address, even you change or modify this variable's value, it does not affect the actual values stored in the array elements. So that's the difference between pass-by reference and pass-by value. Okay, let's go back to the slides. So we have just looked at the range-based for loop, which is a newly introduced features in C++. Let me introduce you some of pitfalls, the mistakes, common mistakes when we are dealing with branch and loop statements. And so I found very interesting mistakes from students when they are working on programming exercise 3. I'd like to share them in this class. Program exercise 3 asks students to check the integer is range from 1 to this big number, 2 to the power 31 minus 1, which is this number. So the students check these integer ranges in two different ways, by using this way or using power functions in math library. So some students use these literal constants to check the integer range, and some students use these power functions in math class, math library. But the this one has some problem. Let's see the example code. So I copy and paste the student's source code. So this is the student source code. He or she check the range users input 1 to this big number by using these power functions and using these condition statements. So let's run this program and see whether it executes as expected. So if we run this, I simplified code. So if we run this code, it's waiting users input in this line. So I will put 1 and I will put this big number. This program should not throw this error message because this is expected ranges input. But as you can see here, this program unexpectedly throwing error message this one, even though we entered the correct range value, correct range of int value. Do you see why this is happening? I will give 10 seconds to think about this one. Think about why this is happening. Okay, so let's discuss this with me. So I copy these expressions here and print this the results of these expressions here. So let me remove this line. Now let's see the evaluation results of these expressions. If we execute this program, this expression results to this value. Our expectations of this, our expectation result should be this one, but the actual output of this expression is this one. So since this expression is 46, not 47, that is the reason why when we enter this 47 number, it throws this error message. So why this expression produce this unexpected value, the 46? Think about this for 5 seconds. Why this expression produce this value? Because 2 to the power of 31 is this this value, 48, and minus 1 should produce this value. But why this expression produce this 46? Okay, so let me explain you about this one. This function returns the this big number 48, and this big number is bigger than the maximum data size that int data type can store. The maximum data size that int type can store is this number, the 47, which is smaller than 48. So what this one doing is that it's casting this bigger number to the data type smaller than expected. So we cannot cast this big number to int type because int type cannot hold this big number. So unexpected behavior comes here when we are casting data type here. So depending on the compiler's implementations, the program may produce different outputs. So in my local machine, this expression produces this value, but in the GROOM platform, this expression produces this value. So this is undefined behaviors. So that is the reason why this expression did not correctly check the int range. So be careful when you are casting to another data types. You have to worry about the maximum and minimum data size of the targeted convert type, data type. Okay, so this was one of the interesting students' mistakes in program exercise 3. Let's go back to the slide. Okay, another interesting mistake from students on exercise 3 is integer overflow in for loop. Let's look at the example code right away. Okay, so I simplified the student source code here. You know that we are expecting users input ranging from 1 to this big number for exercise 3. So assume that user enter this big number as a second input and 1 as a first input here. Do you see any problems in this source code? Let's compile this code. Let me print min value here so that we can check whether this for loop is working correctly. Let's compile again. So if I enter 1, 5, so 1 goes to this min, 5 goes to this max, it iterates over 1 to 5 and prints 1 to 5. It looks like this program works correctly. Move this line now. But what happens if we put more bigger number? So put like 5 as a min value and 7 as a max value. This integer range is still valid because it's within 1 to this big number range. When I enter this one, as you can see that even though I comment out this one because I did not recompile, this is not affected. So as you can see here, this min number is printing. The negative min number is keep printing it. And because of this, this for loop does not terminate. It keeps on printing it. So if I comment this out and compile this and run it, 5, 7. As you can see, the program hangs. It does not terminate because, as you can see before, it keep printing the negative big numbers. Why this is happening? This is due to the integer overflow. Let's compile this again. Let's see whether this is working. So for 3, 7. So this is the output of this program. I forcefully terminate this program during the execution. So let's see why it prints the negative number. So my input was mean value was this one, 43, and the max value was 47. So the loop starts from mean to max. So it starts from this big number 43. And as expected, it iterates here, over here, 47 here. After this iteration here, our expectation was terminating this for loop, because if we plus 1 this number, it becomes 48. So 48 is bigger than 47. So our expectation was terminating the for loop in here. But when we plus 1 this number here, it does not produce 48 this number instead, but it produced the negative number here because that int data type can, the maximum data type, sorry, the maximum int data type can hold is this value. So if we print plus 1 this value, because max is an int type, so if we plus 1 in this value, it overflows the memory locations, and so the negative values comes here. So in the next iteration, we plus 1 here, so it's 47, and plus 1 here, so it's 46. So next one, plus 1, 45, so and so on. It keeps on looping these iterations. So here, because of this integer overflow in this increment statements, this for loop does not terminate. This was the one interesting mistake from the students. So let's go back to the slides again. The another pitfall I'd like to introduce is short circuit evaluations. So short circuit is one of the optimization steps of the compiler. It avoids unnecessary calculations. So let's see example here. So this is a AND operator. In AND operator, this whole condition expression returns true if both left and right side expression evaluates to true. So if left side return false, this whole condition expression return false regardless of the result of these right side expressions. So the compiler does not evaluate the right side expressions of AND operator if the left side of the AND operator returns false. So this method of evaluation is called short circuit evaluations. So using this, compiler can avoid unnecessary calculations. So because these short circuit evaluations in compiler, you have to be careful sometimes. So For here, let's assume that the programmer's intention was to increase the value of y variable by 1. So using these statements. But if the left side evaluates to false, the right side expression will never be executed because of this short circuit evaluation method. So the value of y will not be increased by 1, which leads to the unexpected behavior from the program. So be careful about the short circuit evaluation when you are developing a program. The next pitfall is about forgetting break in switch statements. So this is very simple switch statement. The intention is to print 1 if this value is 1, and prints 2 if this value is 2, and print 3 if this value is 3. Let's see the example code for this one. So this is the example code we just saw in the slide. So if the value is 1, the control flow goes to this case. And if this value is 2, the control flow goes this case. And if the value is 3, the control flow goes this case. So let's say this value is 3 and compile this code and see the program's output. So if I compile this program and run it, this program produces 3 here. Because the value is 3, the control flow goes this case statements and print 3 and break. But what happened if the value is 1? The expectations was the expected result of this program is just print 1 and breaks the statements. So if I compile it and if I run it, unlike the expected, even though value is 1, it prints 1, it also prints 2 as well. So this is because that break statement is missing here. Because this value is 1, the control flow goes to this case and it prints 1. Because there's no break statement, control flow goes to this case 2 and prints 2. And because now there is a break, switchment terminates here. So surely this is not expected result from the programmer. So don't forget to put the break statements when you finish at the end of each case statement. As you can see that even though you unintentionally put the break statement at the end of the case statements, compiler does not show any warnings or error message. So it's programmer's responsibility to properly put the break in switch statements. So be careful about this one. We'll go back to the slides now. Okay, the next pitfall is loop pitfall. You know while loop already. The while loop keeps iterate until the expression here returns false. So if the expression here evaluates to true, while loop keep iterate here. So the intention of this code is to print 1 to 10. So for example, the initial value of count is 0. because 0 is smaller than 10, this expression evaluates to true, so it goes into the body of while loop. So it increased the count by 1, so count changed to 1. So it prints 1, and it goes back to here and checks the expression here again. Now count is 1. 1 is still less than 10, so this expression evaluates to true, so it goes into the body of while loops and increase the count value by 1, so count now becomes 2, and it prints 2 here and goes back to here and checks the expression again. So it prints 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and when the counts become 11, because 11 is greater than 10, these expressions evaluates to false. So in that case, the while loop terminates. So the expected results of this program is to print 1 to 10. Do you think this program will print 1 to 10 as expected? I will give 20 seconds to think about this one. Okay, let's run this code to see whether this program prints 1 to 10. Oh, I think, yeah. So this is the code we have just looked at it. So if I compile this code, okay. So if I run this code, our expectation is that this program should print 1 to 10. But if we run this program, as you can see here, the program does not print any numbers, which is unexpected. And second, the while loop or something is not going properly, so this program does not terminate. So why this is happening? This is because semicolon here. Because of this semicolon here, this is not a while loop body. So this is not while loop statements. While loop statement finishes in this line. So the only line 6 is the while loop statements. But because there is no code for increasing the count value in here, the count value is always 0. So these expressions always evaluates to true because count number is always 0, which is less than 10. So that is the reason why this while loop leads to the infinite while loop. It does not terminate. So this is the reason why this program does not print this file any numbers, because and the program does not terminate because the program hangs in here. So be careful about this semicolon when you are using a while loop. Okay, so in these sessions, we learned about the range-based for loop, the range-based for loop is very useful in iterating array. It makes your program code simple and easy to understand. And we also study about some of the pitfalls when we are dealing with a loop and condition statement. So that's it for today. See you next time.